Today we're going to look at lesson 3, x and y intercepts, and how they're important in relations. So a quick review here. Okay, a relation is a connection between two quantities, okay, and it can be represented graphically by a set of ordered pairs. The first component of a set of ordered pairs, for example, if I have something like 3, negative 5, that's an ordered pair. The first component of the set of ordered pairs is the x-coordinate, in this case the 3, also known as the input, and the values of the input are the independent variable. Now, the second component is the y. Okay, so this would be the y over here, so negative 5, also known as the output, and the output values are called a dependent variable. In other words, the y values depend upon what the x values are. Okay. All right. Now this next little section you're gonna have to do on your own. Anytime you see exploring, make sure you go ahead through this on your own and see if you can figure out what x and y intercepts are just by doing some plotting. I'm just gonna give you a quick tip here. Okay. Remember that the graph is the thing that you draw on the Cartesian plane. So in this case, this would be the graph. Here, this would be the graph. And then the circle here would be the graph. Okay, the axes are, again, the x-axis is the red here. That's the horizontal. Okay, and the y-axis is the green. Okay, so remember, just those three things. Okay, all right, moving on. So again, go through all this, fill this out, see if you can make your own conclusion about x and y intercepts, and then finally make sure you get the definitions down of both the x and y intercept. So go ahead and pause the video and read this, and I'm going to jump into example number 1. Okay, in equation of graph number 1, on the previous page, which was 3y equals 5x plus 15, algebraically determine the values of the x-intercept and the y-intercept. Okay, the most important thing you have to remember is that for all x-intercepts, the y-coordinate is always going to be 0. So it's going to be some x value, comma 0, because the x-intercepts go through the y-axis. And for the y-intercept, the x-coordinate is always 0, and then some y-coordinate, depending on the equation. Okay, so how do I figure out what the x-intercept is? Well, I first write my equation down, 3y equals 5x plus 15, and then it's just a matter of substitution for the y value. So it'd be 3, and then I'll put a bracket there, 5x plus 15, and finally I'm going to put the 0 in here because that is the y value that we're going to substitute in order to find the x value or the x-intercept. Okay, so I have 0 over here, 5x minus plus 15. Subtract 15 from both sides. And then finally I have x equals negative 3. So that is the x-intercept for this case. That the ordered pair would be negative 3 and 0. Okay, and if we were to plot that, I'll go ahead and plot it over here. That would be somewhere about 0 or negative 3, 1, 2, 3, and then it would be right on the axis, so it would be right over here. For the y-intercept, I'm going to do a very similar thing, except this time I'm going to make the x equal 0 because again, the y-intercept goes through the y-axis. Okay, so the same equation, 3y equals 5x plus 15, 3y equals 5, and then I'm going to, instead of the x, I'm going to put in the 0. Okay, because again, I'm looking for what the y value is when when x equals 0 this time. So 3y equals 15 and y equals 5. So the ordered pair, and always write the ordered pair down, okay, is 0, 5. And I'm going to go ahead and plot that on the grid. So again, 0 is right on the y-axis. 0 and then 5, 1, 2, 3, 4, 5 right there. And you'll notice that all you need is 2 points to come up with your equation of the line. Okay, there it is. So there's your graph. Okay, let's do okay, for this next one, you'll see the equation is a little bit more complicated. So I have x squared plus y squared equals 16. And again, the key thing here, to find the x-intercept, I need to make my y 0. So it's going to be x comma 0, and then 0 comma y for the y-intercept. Okay. So again, all I'm going to do is I'm going to make my my y coordinate 0. All right, and then it's going to be x squared plus 0 equals 16, because 0 squared is 0. So x squared equals 16. And then finally, x equals plus or minus 4. Okay, after I take the square root. Okay, so what you see here is that this equation is going to have 2 x-intercepts. Okay, and they are negative. Well, let me write them as ordered pairs. So positive 4 and 0, and negative 4 and 0. Okay, so I'm going to go ahead and again plot that over here. Let me make my graph. There's the y-axis, there's the x-axis. So 4 and 0 would be 1, 2, 3, 4. And you can tell that as long as you're on the x-axis, that is the x-intercept. So if I came out to an answer that plotted up here, well, that would be wrong, because that's not the x-intercept. It's not touching the x-axis. Okay, and then negative 4, 1, 2, 3, 4, and 0 is right over here. Okay, so there are 2 x-intercepts, and that's perfectly okay. All right, for the y-intercepts, it's going to be the same equation, x squared plus y squared equals 16, except this time I'm going to make the x is 0 plus y squared equals 16, and you'll notice that you actually get the same answer plus or minus 4. Okay, and I'll show you, you'll see this case is going to be a very special case that you're going to look at more in depth in grade 11. So again, the ordered pairs are, let me write them in green here, are 0, 4 and 0, negative 4. Okay, so those would be 0, 4 would be again 1, 2, 3, 4, because the 0 is right on there. We don't go left or right, it's just up and down. 1, 2, 3, 4. And you'll see what we actually graph is a circle. Do my best here to make a good circle. Okay, so anytime you see x squared and a y squared in an equation, you're going to get some sort of a circle or elliptical shape. All right, now let's do a practical example here. It says Lisa purchased a new car for $20,000. The value of the car can be represented by the formula V equals 20,000 minus 1,250 T. And this is now important, where V is the value of the car in dollars, so that's the value of the car in dollars, and T is the age of the car in years. Okay, so let's just let's look at our axis first here, or our Cartesian plane. You'll see that on the y-axis I have the value of the car, because that is the dependent variable. You always want to identify what the variables are. Okay, and the age of the car down here, age, and then value of the car goes on the y-axis. again, the value depends upon the age of the car. It's not the other way around. The age of the car does not depend upon the value. Okay. All right. So let's go ahead and complete the table. So I'm going to have to do some math here. I'm going to try and do as much of it as I can in my head. Again, the input, when the input is 0, I'm going to go ahead and substitute 0 in here. Maybe I'll do it over here. V equals 20,000 minus 1250 t. So V equals 20,000 minus, and then when t is 0, well, it's just going to be 20,000. So the ordered pair is 0, 20,000. Okay. When t is 2, so that's going to be 1250 times 2. That's going to be 20,000 minus 2,500. And the answer is going to be 17,050. Rather 17,500. Okay. I'm going to go ahead and fill up all of those so we don't have to spend a lot of time doing the easy math here. This one's 15,000. And this one is 12,500. Sorry, this should be a 2 over here. This should be a 4. That's a 4, 1,500. And then 6 and 12,500. Okay, now complete the... Oh, the question says complete the table of values and plot the ordered pairs. Okay, let's plot those. So 0 to 20,000 is, well, when the car is 0 years old. Okay, I'm going to do this in green here. It is 20,000. So there's the first one. Then when the car is 2 years old, and again, where's 2 would be 1, 2 over here, so that's 2. It is 17,500, so I'm going to go up 17,500. When it is 4 years old, it is 15,000. 4 years old, it is 15,000. And then 6 years old, 12,500. 12,000, where is it? Down here. There it is. Okay, so those are the only points I have. I'm going to connect these in a straight line because, again, the car can be, it can take on any age between the ages of 0 and 2. It doesn't go from 0 then to 2. It can be 0, 0.1, 0.2, all the way to 1, all the way to 2, every value. So therefore that is a continuous variable. So I'm going to go ahead and connect all the dots, and eventually your graph will go all the way down here. If I can do my best straight line. Okay. All right. So the question says here, B is kind of important. What does the ordered pair 0, 2000 mean? Well, what it means, simply put, the car is brand new. Okay. In other words, the car, when it was bought, it was $20,000. Okay. It says use the graph to estimate the t-intercept. What does the t-intercept mean? So the t-intercept, I guess that would be down here. The v-intercept would be here, the value intercept. So, if I'm looking at this thing over here, this coordinate would probably be something like 16, 17, 18, comma 18, comma 0. Okay, well, 18, comma 0. Unfortunately, what this means is that the car is now a piece of junk. It's worth nothing. It's 18 years old. The car is worth $0. Okay, the car is brand new here. It's worth $20,000, and then 18 years later, the car falls apart and it's worth nothing. Okay. It says, use the graph to estimate the value of the car after 3 years. After 3 years, the car, well, that would be here. Let me see if I can do my best estimate. The car would be, I'm going to go all the way up until I hit the graph. Right about there. Okay, the car is $16,000. How do I read that? I go across and read the $16,000. After 10 years, 10 years, the car is about, there's 10 years, the car is about $8,000. And after 14 years, the car is, let me see here. I'm going to, try and guess right about here. So $4,000 after 14 years. And then use the formula to verify. Again, I'm just going to verify only one of these just to save some time here. So again, what is our formula? Well, our formula is value equals 20,000 minus 1250t. Okay, so let's verify this. Let's put in, I don't know, let's try the 10 one. There's the 10. So it's 20,000 minus 1250 times 10. And 1250 times 10. So let me figure this one out. So that would be 7,500, I believe. And what did we guess? Well, we guessed 8,000. So we're a little bit off. My graph is not, my perfect line is not really a perfect line. So I was a little bit off. So always, either use a ruler when you're drawing your straight lines. Okay, and as a matter of fact, I'm going to take out my straight line little thing on the program here. Let me see if that would if I can find the straight line. Draw. There it is. There's my straight line. All right, let's see if I can do this. Here we go. And I'm going to go through these points because those points are for sure correct. Okay, now let me see if I can. This might be a little bit tricky. Oh. There it is. Okay, so yeah, my line was a little bit off. Okay, there's the actual line in blue. So that's a better. So I can see that the car is going to be, it's going to turn into a junker before 18 years old. Looks like it's about 16 and a little bit over here. There's the real x-intercept. Okay. All right. Use the graph here. Let's work backwards now for F here. It says use the graph to estimate when the car will be worth $5,000. Okay, so this is working backwards. I'm going to use my black pen for that. So again, I find $5,000, and that's right here. And I go to my graph. I'm going to go to the one in blue now, and then go straight down. And looks like at about 12 years old, 12 years, the car is $5,000. Half of the value, the original was 20,000, so half the value is 10,000. That's right about here. So I'm going to go down, and it looks like it's at about 8 years old there. Okay. Use the formula to verify, of course. So the value equals 20,000 minus 1250t. Let's check only one. I'll check the 12-year option. So I will put 5,000 and see what the time comes out to be. 1250t. And when I solve for t, it indeed will be 12 years. Okay, so complete the following statement to describe the relation. The original value of the car was 20,000. It depreciates in value by, well, here is what the kind of what I'm hoping you get out of this is that every year, per year here, the car drops by a value of $1,250. Okay, so every year the car is worth less and less and less. It has no value after about, what do we say here? After about 16 years. Okay, all right. Hopefully you had fun watching a more practical example of our x and y intercepts and our graphing. Okay, see you next time.